So what does this mean? What this means is an angle inscribed in a semicircle is a right angle. Do we all agree a semicircle is half a circle? And what is that special line that splits a circle in half? What is it called? That special line that splits a circle in half? A diameter. So what this theorem is saying is if I have an inscribed angle is an angle whose vertex is on the circle. So if I have an inscribed angle, is if you're looking at it like a Pac-Man mouth, if it's eating the full diameter, see how this angle is eating the full diameter and its point, the vertex point of it, the pointy part of the angle is on the circle. That means this angle is going to be a right angle. So if an angle whose vertex is on the rim of the circle is eating the full diameter, that angle will always be a right angle. That's what this theorem is saying. All right, next thing. A polygon is considered inscribed in a circle if all corners are on the rim of the circle. So what does that mean? See how I just drew a triangle inside the circle, but do you notice that all the corners or the vertices of the triangle are on the rim of the circle? That means the triangle is inscribed in the circle. That's how you would say that this triangle is inscribed in the circle. If I drew it like this, is this triangle that I just drew in black inscribed in the circle? No, why not? Why is that bad? Its corners aren't where? Good. The corners are not on the rim of the circle. So this triangle is not inscribed in the circle. All right. Theorem. If a quadrilateral is inscribed in a circle, the opposite angles are supplementary. All right, what does this mean? Do we all agree the quadrilateral means four-sided shape? That this four-sided shape is inscribed in the circle because all of its corners are on the rim of the circle? So now I'm saying if that's a scenario, if a four-sided polygon is inscribed in a circle, the angles across from each other add up to 180. So that means angle A plus angle C, those are opposite angles, equal 180. And what else should equal 180? What two angles? Yep, angle B plus angle D equals 180. Okay, so that's the end of day 3 notes. Let's now go and do our day 3 class kick. So the class kick is the second one in the second column. Let's skip this do now and go right into the lesson. Oh, wait, circumference and area also. Hold on, let me see. I think I need to go back to some of the lesson. Yeah, sorry guys. We need to go through that last page. Sorry. Go back to our guided notes. This last page too. Okay. To find the circumference of a circle, you guys should all be pretty good with this from middle school. Circumference is equal to 2 times pi times the radius, or 2 times pi times the diameter. So r is the radius, r equals radius, and d equals diameter. Oh, sorry, not 2, sorry, pi d, not 2 times pi d. That wouldn't make any sense. Pi d. So isn't 2 times the radius the diameter, right? So that's why these formulas are the same thing. Now, when we talk about the circumference of the circle, let me just explain to you real quick. Let's say this is my circle P, okay? And if I want to find the circumference of the circle, it's sort of the length of the whole circle. So if this circle was a string, and I put it, like I moved that string to look like a circle, and then I were to take that string and pull it straight, the circumference tells me how long that string would be that made this circle. So that's what we're doing when we're finding the circumference. So if I have a circle that's made out of a string and I were to take that string and pull it straight, it's telling me how long that string is. So essentially the circumference is almost like the perimeter of a circle. But because a circle doesn't have sides, you can't really say we're finding the perimeter because there are no sides, but it's essentially telling us how long this circle is on the outside. All right, so now when we talk about arc length, remember an arc we talked about was a pathway between 2 points on a circle. So here, if I have arc AB, and I want to find not how long just the whole circle is, I want to find how long just the arc AB is. Well, it's not a segment, right? And if I say arc AB is 20 degrees, that's not telling me how long it is. That's telling me the measure of its degrees. So if I wanted to find how long just the arc AB is, there's a special formula we're going to use. And that special formula is going to be the arc degree. Oops, sorry. The arc degree over 360. So by me doing the arc degree over 360, it's really telling me what fractional part that arc is taking up of the circle. And then what I'm going to do is I'm going to multiply it by the whole circumference of the circle. So let's say I end up that arc AB is 1/6 of the whole circle. Well, if arc AB is 1/6 of the circle, shouldn't its perimeter be 1/6 of the whole perimeter or the whole circumference of the circle? Okay, now everybody always confuses these two. Circumference is the perimeter, it's the outside of the circle. Area is not outside. What's area? Inside, yep, the whole area inside. So to find the area of a circle, it's going to be the area is equal to pi times the radius squared. And now let's talk about what a sector is. So do we agree if we're finding the area of a circle, I'm finding the whole inside area, what I'm highlighting in yellow? Do we agree? Now, a sector is basically if I have a central angle The sector is going to be the area within the central angle. What I just shaded in green, that's the sector. So now, wouldn't the area of the sector just be a fractional part of the area of the whole circle? So the way we're going to do this, to find the area of a sector, it's going to equal, again, the arc degree over 360 to figure out how much the sector is taking in, times now, not the circumference of the circle, but the area of the circle, pi r squared. We are not going to go over the standard form of an equation of a circle, so we could cross that out. Okie doke. Let's now go to the class kick. We're going to skip that do now just to save time. And now let's do some of these problems. So it says angle Q is 100 minus 2x, and angle A is 7x plus 30. Oh, I didn't make a copy. Sorry, guys. That was helpful. Was that weird for you all? Okay, this one should not be writing. There we go. So now we're going to have one is not the do now. One is one. Okay, let's do two since we started. Oh, well, I erased it anyway. Okay, let's just do one. So it says arc BCD, arc BCD. Now remember, arc BCD is a major arc, so it's going from B to C to D. So this is the arc that I just sort of looped out in pink, is 208 degrees. And the first thing we want to do is find angle A. Well, angle A, isn't this an on angle, an inscribed angle? So now I don't know if it's eating the diameter because there is no diameter drawn, right? So I can't assume that it's eating the diameter because there's no diameter drawn. So I can't say it's a right angle. But we learned the formula saying an inscribed angle ends up being the arc that it's eating divided by 2. Well, isn't it eating that whole arc from B to C to D? So that means angle A is going to be that 208 divided by 2. So angle A is going to be 104 degrees. Because we had learned a formula that an inscribed angle, so an angle whose vertex is on the circle, ends up being whatever arc it's eating, if it's a Pac-Man mouth, divided by 2. And so since it's eating that whole 208 degrees, we divide that by 2. Now we just learned a formula, or a theorem, I should say. Because this is a quadrilateral, a four-sided polygon inscribed in a circle, what did we say about the angles that are across from each other? They have to add up to what? 180. So the next thing we want to do is find angle C. So if I'm finding angle C, wouldn't angle C be across from angle A? So I do 180 minus 104. So I'm going to need to borrow here, and we're going to get 76 degrees for angle C. And how do you think we're going to find angle D? Excellent. Again, angle D and angle B add up to 180. So for angle D, I'm going to do 180 minus 76. Oh, sorry, 67. Good catch, Jay. Thank you. So 10 minus 7 is 3, 7 minus 6 is 1. We get 113. Okay, I want you guys to set up number 2 yet now. Well, actually do number 2. I have a feeling you guys could figure out number 2 all on your own. Try number 2. So I started off by labeling my information into the diagram. And once you label the information into the diagram, what is it that I hope you remember? That if a quadrilateral is inscribed in the circle, then the angles across from each other do what? If a quadrilateral is inscribed in a circle, what do we know about the angles across from each other? They equal 180. They add up to 180. So your equation should have been 100 minus 2x plus 7x plus 30 equals 180. How many people at least knew to set up that equation from there? Awesome. So now we check our equation solving skills. So I have a negative 2x and a 7x, which gives me 5x. I have a 100 plus a 30, which gives me 130 equals 180. Now to solve, I'm going to subtract 130 on both sides. So I have 5x is equal to 50. Divide by 5, and I get x is equal to 10. Sebastian, is 10 my answer? No, what am I asking for? Angle Q. So now that I know that x is 10, what do I do to find angle Q? Perfect. So I know angle Q is 100 minus 2x. So I'm going to plug in the 10 for x. So that's 100 minus 2 times 10. So that's 100 minus 20, which is 80 degrees. So angle Q is 80 degrees. Okay, we're going to skip number 3. Let's go to number 4 on the next page. So it says circle B. It's telling me arc AD is 60 degrees. Now look at this. I love how I have both of these here. Arc AD is 60 degrees, but then what is it saying? Segment AD is 12. Find the perimeter of triangle ACD. So, couple of things. Because it told me circle B, do we all agree that AC is a diameter, splitting that circle in half? Since AC is the diameter, and you guys see angle ADC, see how D is an on angle? So its vertex is on the circle, so it's an inscribed angle. And now this inscribed angle is eating the full diameter. If it's eating the full diameter, what does it have to be? What kind of angle? A right angle. Everybody okay with everything I've labeled so far? Now here's the tricky part of the problem. Are you ready? Okay. So the tricky part of the problem is I want to find the perimeter. All I have is one side. I don't have anything to find the other sides, but I do know, oops, I do know that arc AD right here is 60 degrees, and I know angle C is an on angle. Do you guys see how angle C is eating the arc AD? So it's an on angle, it's an inscribed angle, and it's eating arc AD. What did we just say from a couple of problems ago? That inscribed angle is what compared to the arc that it's eating? The arc divided by 2. So if arc AD is 60, angle C has to be 30. So now what kinds of triangle am I dealing with? A 30, 60, 90. Remember I told you that these triangles never go away. Chapter 9 keeps finding its way back into everything. So now I'm going to redraw A, C, D. I know that AD is 12. Angle C is 30. That means angle A is 60. So now we have to remember that across from the 30 is X. Across from the 60 is x root 3, and across from the 90 is 2x. If I'm going too fast, just tell me to slow down. So now, do we agree that x has to equal 12? So now I know x is equal to 12. Well, if x is equal to 12, how long is AC? 24, 2 times 12. And DC is going to be 12 times the square root of 3. Does anybody need me to re-explain how I got 24 and 12 root 3? We're okay? Okay, so now the perimeter is going to be 12 plus 24 plus 12 root 3. You could only add the like terms. And so I could only add the 12 and the 24, and I get 36 plus 12 root 3. So now to type this in, don't click the box at all. Click the typewriter or the keyboard. Click the keyboard, and you're going to say, it wasn't 12. Oh, go back. Oops. We're going to say keyboard 36, and then see that square root all the way to the right. Oops, sorry. I messed up. That should have been 36 plus. Try this again. 12 square root 3. It still doesn't work?
Me neither. Mine doesn't work either. Well, when I was doing it, when I was doing my homework, it was working, but now that back did not work. Like I was doing my homework, but I was doing it here, like after school, and I got it to work, and then now I don't. Like when you click it, like click it with like there's a gray like bar comes up at the bottom of. I don't know if I ever get it. Yeah, I don't know how to get it. I don't know. Like, yeah, I don't know why it doesn't work. It's so odd. I know, like it was working me now.
That's okay, because you have your answer here.
Okay.
Okay, so it's fine. Yeah, just box your answer.
Okay, next one. Given circle O, the radius is 6. Do you guys see any right angles here? Which angles can I mark as right angles because of that inscribed eating the diameter? Do you guys remember that theorem, inscribed eating the diameter? So which angles can I mark as right angles? Jay? You got it. Angle H and angle G. And so then it says the radius is 6. Well, do you guys see how EF is not a radius, it's a whole diameter? Since EF is a whole diameter, it's not going to be 6, but it's going to be what? Since the radius is 6, the diameter has to be 12. 2 times the radius. So now I'm going to use this triangle, HFE, and I know across from the 60, across from the EF is 12. So across from the 30 is X, across from the 60 is X root 3, and across from the 90 is 2X. Does anybody know the equation I'm going to write to solve for X? How am I going to find X here? Noah? You got it. 2X equals 12, so X will equal 6. So now that X is equal to 6, that tells me that HE is 6. And what's HF going to be? Good, Jay, 6 root 3. So HF is 6 root 3. And since this is a rectangle, across from it will also be 6 root 3. And if HE is 6, then across from it will also be 6. So now the perimeter is going to be 6 plus 6 plus 6 root 3 plus 6 root 3. So the perimeter is going to be 12 plus 12 root 3. So we're going to say 12 plus 12 root 3. All right, we're going to skip number 6. Let's go to page 3. Okay, if the radius of a circle is 8 centimeters, find the circumference. So now we have to remember the circumference formula. So the circumference formula is C equals 2 pi r, or C is equal to pi times the diameter. Now, what is it telling me? It says if the radius of the circle is 8, since they're telling me the radius, do you think I'm going to use the formula with the radius or with the diameter? With the radius. Since they're telling me the radius, I'm going to use the formula with the radius. So we're going to say C is equal to 2 times pi times the radius, which is 8. Everybody okay with how I've plugged in so far? Now, for all these problems, we don't put 3.14 for pi. I know in the middle school, they used to make you do that. We just leave the pi symbol. So what do I mean by that? You're going to multiply the two numbers that you can. So 2 times 8 is 16, and then you just put the pi times pi. And so when we go to type this in, you're going to do 16, and then the pi is all the way to the right. Oh, my battery's getting low. Let me get my charger. It has to do with your pen. Like if you put your pen inside and then try to type it, see if that works. No, still. Are you on the pointer or are you on the marker? Yeah, that's so odd.
Like, yeah, because I was here after school and I was doing it.
And it worked.
But like,
Okay, number 8, it says find the circumference of a circle with a diameter of 52. Now remember, our two formulas are C equals 2 pi r or C equals pi d. But this time they're telling us the diameter. Because they're telling us the diameter this time, do you think I'm going to use the 2 pi r or the pi d? Pi d. So we're going to say C is equal to sorry, pi times 52. And so we just write this as 52 pi. That's it. Really no algebra to do there. Okay, so now this is where it gets a little bit sneaky. You ready? If the circumference of a circle is 4 pi, find the radius. So because they're talking about circumference, oops, I don't want that. Because they're talking about circumference and then they're telling us part A, find the radius, I'm going to go with the C equals 2 times pi times r. But this is where it's very sneaky. In the past, I've given you the radius and I've asked you to find the circumference. But this time, I'm telling you the circumference is 4 pi. Since I'm telling you the circumference is 4 pi, do you see, instead of C, because that's where circumference is, I'm going to type in 4 pi. Or I'm going to replace it with 4 pi equals 2 times pi times r. Is everybody okay with why I put the 4 pi where I put it? Okay, now the first thing we're doing is solving for the radius. So we're going to go back to solving equations. I need to solve for r. If I need to solve for r, I need to get it in a box all by itself, which means I have to get rid of the 2 and I have to get rid of the pi. Do we all agree the 2 and the pi are being multiplied with the r? So to undo multiplication, I'm going to perform division. So I'm going to divide by 2 pi on both sides. And when I divide by 2 pi on both sides, on the right side, the 2 pi cancels. On the left side, just the pi cancels. So now I'm left with the radius is equal to 4 divided by 2. Well, what's 4 divided by 2? 2. So now I go back up. The radius is 2. And what's the relationship between the radius and the diameter? Good. The radius is half the diameter, or the diameter is 2 times the radius, right? So the diameter has to be 4. Yes. Yep. Okay, I want you guys to try 11 and 12. We're going to skip 10. Try 11 and 12 on your own. In the diagram, what does this 6 represent here? The radius, very good. In the diagram, that 6 is the radius. So for number 11, you should have done C equals 2 times pi times r, or 2 pi r, however you want to write it. So this is going to be 2 times pi times 6. So C is equal to 12 pi. How many people got that correct? Yay, you. 12 pi. All right, for the second one, did you guys start that yet, or do you need another minute? Another minute? Okay, I'll give you another minute for number 12. So for number 12, I'm going to say C is equal to 2 times pi times r. But this time again, I'm telling you the circumference is 62 pi. So where am I putting that 62 pi for which variable? C or pi or r? C. So we're going to say 62 pi equals 2 times pi times r. Now CD, it says find CD. Isn't CD the radius? So I'm trying to solve for the radius. For me to solve for the radius, I'm going to divide by 2 pi. And when I divide by 2 pi, the pi's cancel. So my radius is going to be 62 divided by 2, which is 31. All right, last problems for today. Go to your next page. We're not going to go to page 5. We're going to only go to page 4. All right, so it says if the radius of a circle is 8 centimeters, find the area. Well, remember, area formula is different. The area of a circle is going to be pi r squared. So the area of a circle is going to be pi times 8 squared because it says the radius is 8. Is 8 squared 16? No. 8 squared is 8 times 8, which is 64. So the area of our circle is 64 pi. So now it says find the area of a circle whose diameter is 22. Well, there's only one formula for area of a circle, pi r squared. There's no option for diameter. I can't plug in that 22 into my formula. But if I know that my diameter is 22, what does that mean the radius has to be? 11. So remember, the diameter is always double the radius. The radius is half the diameter. So now this is going to be the area of the circle is pi 11 squared. So the area of the circle is going to be 121 pi. Okay, so now I'm going to make things a little bit tricky. If the area of a if a circle has an area of 16 pi, find the radius. So this one's a little bit tricky because now I'm telling you the area is 16 pi. So I'm going to write out the area formula. Area equals pi r squared. But because it says the area is 16 pi, I'm going to put 16 pi for A. And I need to solve for r. For me to solve for r, I first have to get rid of the pi. Now the pi and the radius squared are being multiplied together, so I'm going to divide by pi on both sides. And when I divide by pi, the pi's cancel on both sides. So now I'm going to have the radius squared equals 16. This is not the radius. This is the radius squared. Who remembers, how do I undo a square? What must I take of it? To undo a square, you must take the square root. So now the square root of r squared is r. What's the square root of 16? Jay? 4. So now my radius is 4. If the radius is 4, what's the diameter have to be? 8, double the radius. Now I'm getting even more sneaky here. They're saying find the circumference of a circle with an area of 49 pi. So they're saying the area is 49 pi, but then look how sneaky this is. They're asking to find the circumference. Well, to find the circumference, it's 2 times pi times r. In order for me to find the circumference, I need the radius. They didn't tell me the radius or the diameter. All they told me is the area. So now I have to use the area formula. Well, the area is pi r squared. And they're telling me that the area is 49 pi. So I'm going to say 49 pi equals pi r squared. And guess what I'm going to solve for? I'm going to solve for the radius. So now we're going to divide by pi on both sides. So now I have the radius squared equals 49. To undo a square, what must we take? Square root. What's the square root of 49? 7. This is not my answer. What did they ask us to find? The circumference. So why did I do all of this? I did all of this to find the radius so I can plug it in for the circumference. So 2 times 7 is 14. So my circumference is 14 pi. Okay, I want you guys to do 17 and 18 by yourself, and then we'll be done. I know this was a long lesson. So this one, first one is just guys straight plug in. They're saying I've labeled for you that the radius is 6. So this first one is just straight plug in. The second one is plug in but some manipulation. Jay? You finished them? Awesome. Thanks. Who needs another minute for the first one? Anybody? Yeah. So the radius is 6. So it should be area equals pi times 6 squared. Well, what is 6 squared? 36. So it should be area equals 36 pi. How many people got that correct? Great. Now for the second one, this is where it's a little bit manipulated, needs some manipulation. It's saying the area is 64 pi. So area equals pi r squared. But we're going to plug in that 64 pi for A. And now we're going to solve for r. So first we divide by pi. So now you have 64 equals r squared, and then you square root. Square root of 64 is 8. So then it says find CE. Does that mean CE is 8? No, CE is the radius, which is CD. So what would CE be, the whole diameter? 16. The diameter is always double the radius. All right, guys, we are done. You do have homework. I'm going to post that now. Just a heads up.